Welcome to Data Project Hub. In today's video, we will see how to create a sequence of continuous date given a start date and an end date. So we are given a table called as task table. Let me query the table, and from the table we will obtain the start date and end date. Based on the start date and end date, we will create a sequence of continuous date. So given a task table, and in the table we have two columns, start date column and end date column. And these are the two columns that we are going to consider in this question or in this query. The task ID is not considered. We only need start date and end date. From this table, we are going to obtain the minimum start date and the maximum end date. So we will create two variables, and in that variable, we are going to store the minimum start date and maximum end date. And we are going to create continuous date within the range of that minimum start date and minimum end date. For that, the method we are going to use here is recursive SQL. So here we will be using the method of recursive CTE to create a sequence of continuous dates. So first let us create two variables and store the minimum start date and maximum end date in that particular variables. So let us first of all declare two variables, that is declare start date, start underscore date as date equal, we will write a query with respect to the task table, that is select minimum of start underscore date from task table. So this is our first variable, that is start date, and we are going to store minimum of start date from the task table. Now execute this, then we will store the particular minimum start date within the start date variable. Similarly, let us create one more variable which is the end date variable. Declare at the rate of end underscore date, which is of date data type, and write a similar query which is select max of end underscore date from task table, that is task table. Now let us simply write a select star and print the start date and end date which we are getting from the table. This is actually not part of the actual query, but at a later stage when we finally get our output or the sequence of continuous date, it will be helpful for us to validate the result. So select start date comma and end date. Execute this and we will get the minimum of start date and maximum of end date. Execute, and this is the minimum start date and this is the maximum end date. Let us copy this result and let us save it somewhere. Yeah, copy this result, we will paste it over here. So this is our start date and this is our end date. Now we are going to create or write a query using recursive CTE, and we are going to create a perfect calendar or a sequence of continuous date starting from 2024 10/01 to 2024 10/31. So comment this query, that is select at the rate of start date comma at the rate of end date, because that is not part of our actual query. Now coming down, we will start our recursive CTE. First we will start with the base query, that is select at the rate of start underscore date as date underscore column, and this is taken from the initial variable which we have created, that is at the rate of start date. So that is the first part of our query. Now we are going to write a union all clause, that is union all. Now we are going to write the recursive part, that is select. We are going to use a function which is the date add function. Date add, the first argument is day. Now the second argument is going to be the interval, that is 1, and the third argument is at the rate of start date, that is this start date, but we have to mention the date underscore column name, which is the alias name which we have given in our base query, that is date underscore column, and this column name is also date underscore column, and this is taken from our CTE. Now, if we check the query, we can't find any city in the query which we wrote. What we will do here is we will write a with clause, that is with city as. We will place this entire query inside the CTE. Now, this query is the body and this is our CTE name. So, here we are giving the name of CTE only. Now, we are going to write a where condition also within the CTE, that is where date underscore column less than or equal to at the rate of end date. So whenever date underscore column value is less than or equal to end date, the value is going to get incremented by 1. That is, date column value is going to get incremented by 1, and we are going to get a perfect calendar within that particular range. Now after we completed the recursive part, we will simply write a select star from CTE. So we have completed our query. So once again I will go through the query. That is, this is our recursive query starting with CTE as. So CTE is the name of our recursive SQL query, and this is the base query. Select at the rate of start date as date column. Here we are giving date underscore column as the alias name to at the rate of start date variable. Now we are using a union all, and after union all we are writing the second query. This is the recursive part. In that we are using the date function, and within parenthesis the first argument is day, and the second argument is interval, which is 1, and the third argument is date underscore column, which is taken from the base query. And this column is also named as date underscore column from CTE. This is taken from CTE, so that is why the query is called as recursive CTE. And we have a where condition. So whenever the where condition is met, the query will execute, and date column will be added by 1, and we will get a perfect calendar or a sequence of continuous date starting from at start date and ending with at the rate of end date. Execute the complete query and let us see if we are getting some result. Execute this. Now we have some result obtained. Now we can see that we have created a new date column starting with 2024 10/1. And if you remember, we have initially copied the minimum start date and maximum end date from the task table. So this is our minimum start date and this is the maximum end date. Now when we check the date column or the continuous sequence of date which we created, we can see that the start date is 2024 10/1, and the second date is 2. Coming down, you can see that it is 3, 4, 5, 6, 7, and going down, the last date is 2024 11/01. So in order to remove this date, we can make a small change within the query. So instead of less than or equal to, we will use only less than. Execute this, and we will get the final date as 2024 10/31. So this is our end date which we have initially obtained. That is the maximum end date, and the minimum start date is 2024 10/1. Now we have obtained a perfect calendar starting from the minimum start date and ending with the maximum end date. This is how we can create a perfect calendar or a sequence of continuous date in SQL using recursive CTE. Thanks for watching, and if you like this video, subscribe for more. Thank you.